If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
We were looking into studying how to find out various statistics, which curve to be used for which particular scenario. What else were we looking at? Yeah, we learned something about Z statistics, T statistics also, I think. So today's class would be in continuation to that, one more topic in continuation to that, and then we'll go to hypothesis testing. So we'll look at how in real life in industry, what are the steps taken by any statistician to prove his or her hypothesis, and how does today's ecosystem of analytics, which encompasses machine learning and the deep learning concepts also, how do they sit while in terms of setting a hypothesis or testing a hypothesis. Okay, we'll also go through a framework which helps us do that, and we'll try to solve one simple problem using our step that we have understood and prove a particular hypothesis. Okay. So this is basically in continuation to the last class. Here what we are dealing with is how do we estimate the sample size that is needed for my study. Okay. So basically what happens is when you are saying that I have the ability to study and prove something, but then what I'm doing is all data driven, people will always ask you, okay, we understand that it is data driven, but how much data do you need? How many people do we contact, or how many forms do we float? How many consumers do we get the data from? Okay, this is what usually a market research firm does for you, and you have a huge dependency on them. Now, how do you do that? For that, we would look into something called as sample size. Okay. Now, how do we estimate the sample size? If you remember the formula that we discussed last time, that Z is equal to X bar minus mu by sigma by root n. From that formula, probably we can find out what n is. N is usually the number of sample that is taken, right? So when we break down the formula, n becomes Z alpha by 2 whole square sigma square by error square. Now what is E error? Error is the error of your study. How far your mean of the study that you are doing is with the population mean. That is termed as error here. But anyways, we already know the formula, right? So let's look at first question. Suppose a researcher, RT, wants to estimate the average monthly expenditure on bread by a family in Chicago. She wants to be 90% confident of her results. Okay. Now, how much is the error she is willing to tolerate in this result? Can someone answer this?
So we need to find the difference between that X bar minus mu.
Yeah.
How much?
So this is basically this value, right?
Yes.
And then suppose she wants to the estimate to be within $1. So what do you understand by estimate to be within $1? What is $1 here? What is 1 here? If you remember the graph that we were studying, it's a normal graph, and then there is a mean. We say that 1 standard deviation, 2 standard deviation, or 3 standard deviation.
Yes.
What does standard deviation mean? It means,
How far is from the mean?
right? So I want a particular range within which my estimate should lie. That is why I came up with the concept of standard deviation or sigma. Correct? When you express standard deviation in words or in normal regular English, it comes out something like that, that the estimate should be within $1 of the actual figure. Actual figure here is probably average monthly expenditure, which is mean, right?
So you
Am I
mean
right?
so you mean the estimate here describe the standard deviation?
Yeah, I'm asking you that.
Because in further in this problem it says the standard deviation of average monthly bread purchase is $4.
Then what could be 1?
So it's the range of the mean then.
Range of the mean, okay. What do you mean by that? Why is it not standard deviation?
Because I thought like a standard deviation is already there as a $4.
Suppose if this was not given and somebody would say that if the estimate to be within $1, why would it not be standard deviation? We would get confused then, okay. Do you think the standard deviation of any value should be an should it be an estimate in first case 7?
Okay.
Because standard deviation is the deviation of its mean. There you do not do an estimation. Correct? What are you estimating? You are estimating the mean. You are not estimating the standard deviation here. So it is x bar minus mu. I am estimating this value. I have this value. So it has to lie between $1. Can you calculate it, please?
So you mean
What?
the sample mean is we are estimating is means 1?
It should be within 1. Okay, so the difference should be estimate to be within $1 of the actual figure, right? What is the actual figure?
average monthly expenditure that we don't know.
We don't know, right?
Yeah,
Now you don't have a value for this. So you
correct.
can't put x minus something. But we have a value of x bar minus mu, which is 1. We need not worry about mu or
Yeah,
x bar.
okay, okay, now I get. So you mean this could be the error or like difference or range?
Yeah, it is the error, right? I mean, that's what I'm explaining. This is not a standard deviation
Yeah,
from the. So what other thing is missing in this formula? We have standard deviation, which is mentioned explicitly. We have z alpha by 2 that we calculate from ourselves.
yes.
How do we calculate? What is the value of this here? What is alpha here?
Alpha will be 1 minus 0.9.
Correct. And alpha by 2 will be 0.05.
Yes. So point what 1.64 something, I think. I don't know.
Yeah. Correct.
Yeah,
So this we know, we are remaining with this. So probably it will be this only, right?
correct.
But then what I was trying to confuse you with is if
One.
tomorrow someone gives you something like this, you should be able to understand that it is a difference between the two means.
Okay. I
Okay.
got that. Yeah.
Yeah. So can we calculate what
Yeah.
should be the sample size of the estimation of this problem?
Yes.
Harsha, can you also calculate, Vaishali? Both of you.
Yeah, 1 minute.
Norm S inverse. The Excel formula for this.
Can we check what the values are for each?
Sorry?
Can we just check again what is the value for each? 0. Is it 0.1 is alpha? Is it not 0.1 alpha plus 1?
So it is 0.9. So alpha is 0.1.
Yeah, 0.1.
Alpha by 2 is 0.05.
Yeah.
If
E.
you do norm S inverse, you get 1.644.
But norm S inverse is 0.
Uh,
0.05.
Sorry?
Is it 0.05?
Yeah,
No.
because this is alpha by 2, no?
Yeah, 1.6.
1.65 you can use or something.
6.5794.
What? So we are doing.
Oh, now we need to do the square of whole thing. Oh, sorry. Yeah. $43.28.
Yeah, kind of. Vaishali, you also got something like that?
No, I'm still struggling with how to find this E. E is 1.
Yeah. Aarti, meanwhile, why don't you read question number 2 and tell me what is E? what is
Okay.
sigma, what is alpha. I mean, type it, don't tell.
Yeah, I got it. 40.96.
It's somewhere 43 point something. 1.64 whole square into 4 square divided by 1.
Yeah.
Correct. So it is 43 point something. So your formula gives you an answer says 43.3 something. Correct. Now what will you tell it to the business? You would say probably a number which is higher than that always. Why? Because giving a higher estimate decreases your probability of making mistake. Correct. For this case, if you say 43, then it might be more than that. But if you say 44, it is way above it and you are safe. So if you collect 44, your results will look good. Make sense?
Yeah.
So what is this? So let me read out the second question. It says that suppose you want to estimate the average age of all Boeing XX airplanes. Now there is active domestic US service. You want a 95% confidence and you want your estimate to be within 1 year of the actual figure. The XX was first placed in service about 24 years ago, but you believe that no active these airplanes in the US domestic fleet are more than 20 years old. How large of the sample should you take?
So in this case, again, E would
Yeah.
be 1
Okay.
and the standard deviation would be 4.
Okay.
Because 20 to 24 years.
Correct. So what is the
The
alpha? Well,
alpha would be 1.95.5.05, sorry.
right. So 1.96 whole square
Right.
into 4 square
Yeah,
by 1.
correct.
Right. So I'll go ahead then.
So there is one, let me ask you one thing about I
About what?
so like the estimate generally they are asking for 1 year in both questions. So they can phrase in any other form or like in the questions.
Yeah, I mean, you want how much do you want your estimate to be within?
Okay.
Uh, uh,
Go
in
ahead.
real life, also, if anybody will ask you to give an estimate, then what should your questions be? These are your questions. That how much estimate do you think should be there from the actual figure?
Yeah, so generally we will give that time frame or something, maybe, yeah. So that's the
Exactly. So these are the right questions that you should ask
okay.
in order to calculate the sample. Okay.
Okay.
Uh, I'll go ahead then. I think I'll skip the calculation part.
Sure.
Okay. So similarly, as we discussed last time, there is something called as population proportion.
Correct.
So for proportion, there is a bit different calculation where we did a P into Q last time. For the standard deviation. Similarly, for the standard deviation here, we are doing a PQ. That's it. Let me read the question. Hewitt Associate conducted a national survey to determine the extent to which employers are promoting health and fitness among their employees. One of the questions asked was, does your company offer on-site exercise classes? Suppose it was estimated before the study that no more than 40% of the companies would answer yes, correct? So, okay, let me read full, then we'll discuss. How large a sample would Hewitt Associate have to take in estimating the population proportion to ensure a 98% confidence in the result? And it would be within 0.03 of the true population proportion. Okay. So now, what do we have? What is P?
P is 0.03. To be within.
Do you find similarity between this question and this question?
Okay.
Yes, we are trying to find sample.
And what else?
There's a population.
Okay, so let's find out the differences then. Here, the thing is that it was given 24 years and 20 years, or somebody said explicitly the standard deviation is $4, right?
Correct.
Now, in this case, somebody has not done that. There is no difference of two things. Or do we have?
It says, suppose it was estimated before the study that no more than 40% of the companies would answer yes.
Okay, so to remind what is the meaning of P in population proportion. Population proportions P means the probability of success of the experiment that you are trying to do. 40% market share, 30% lead.
Oh, yes, that is the population proportion.
Right?
40%, yeah.
So here we have 40% as population proportion P. Now what
Yes.
will be Q?
0.4.
Q.
Oh, Q will be 1 minus P.
Which is
1 minus 0.4. 0.6.
0.6. Correct?
Error of estimation. Then it will be 0.03.
Yeah, that you found out through the formula.
Right.
But you were confused with what is 0.3.
Yeah.
And to be within 0.3,
We
so
need to
in the
find.
result, 0.3 of the two population proportion. One year of the actual figure.
Yeah, within.
Of the actual figure. You find that similarity?
Yeah.
Go through the question once again after the class. Maybe you'll get a better hold of it. So basically it says how much the result that is required or allowed, how much difference is allowed, your study versus the original study. Now both are means. Your study will also find a mean. The original study also has a mean. So that is x bar minus mu, hence 0.3. Correct?
Yeah.
So why don't we find out the answer? What is the sample size for this, please?
Okay.
Can we get a value of z?
Yes.
How much? Yeah.
2.32. Oh, sorry. No, hold on. How much is it?
What is the value of alpha by 2?
0.01.
Correct.
And then we put in that formula norm dot s dot inverse
Yeah,
0.01, that the value is 2.32.
correct. Two point three two whole square into 0.4 square into 0.6 square, 0.03 square.
Why this will be 0.4 square? Because it doesn't say in the formula.
Sorry, 0.4 into 0.6.
Yeah.
Sorry.
That 344. I made a mistake. No. I think I made a mistake. No. No, this is not the right. $14.34. 1434.
I got a very big number. 14106 something. God.
One 447.707 is what I am getting.
And I got 1434.
I made it 2.33.
No, I did 2.32.
2.32 I got.
0.01, right? 2.32. Chalo. 1435.
Yeah, 5.3. Yeah, 1435.
Correct.
Correct.
So yeah, now we have a hold of finding out the sample size if somebody asks. So where you'll get stuck is understanding which is E. Okay.
Yep.
Focus on that a bit. Rest of the thing is quite okay. So that's over. What we'll do is we'll get into something called as hypothesis testing. Have I introduced this earlier in my previous class?
What was, I'm sorry, I didn't pay attention.
No, you didn't.
Did we discuss hypothesis testing before?
No, nothing.
So how do we say? In anything that we are doing in statistics or using any of our state-of-the-art processes, what we're doing is we're trying to establish a truth. We're trying to find out that the thing that I am thinking or in my head or is in a business head or anybody's thought, is it actually true or not? So what I'll do, I'll have a result that is already existing and I'll compare it with the thing that people are thinking it is. Okay. So suppose I am expecting that a Salman Khan's movie will do 200 crore, but then the producer say it is good this time supposedly, and it is going to be 250 crores. Okay. Now what I'll do is I'll make a hypothesis where I'll consider all the cases and try to see whether it is actually 250 or not. Okay. So I am just all of my study from now on will be based on a test where there will be a hypothesis, which is a scenario that is not proven yet. I will take various statistical tests or various methods available in this world to prove it. Okay. That method is called hypothesis testing. Now, when I go into a little technicality or a bit of depth into it, all the statistical hypothesis consists of two parts: a null hypothesis and an alternate hypothesis. Okay. Now, what do they mean each? What is null hypothesis? As the name suggests, it is the null condition. What usually in our programming language or anything, or our chatbots or anywhere, how do we say something? What is null? Null is something that the state that already exists. Okay, there is no change. Now, for my example, it was 200 crore. Okay. Now, what is alternative hypothesis? Alternate hypothesis states the new theory is true. There are new standards and the system is out of control or something is happening. Correct? So if I am saying Salman Khan's movie will make a 250 crore, that is an alternative hypothesis. Now, if that is true, it means that the old standards have been demolished, a new standard has been set up. Okay. Are we clear about null hypothesis and alternative hypothesis?
So in this null hypothesis, you were saying like in Salman Khan movie, 200 crore. This is from that old data we are like, it's kind of existing, like whenever the new movie release, the Salman Khan, we get generally 200 crore, right? But
Yeah.
the new movie, like for the alternative hypothesis, the director is saying no, we will, like he will get like 250 crore, right?
Right.
Okay. Okay.
So he is moving from the norm, right?
Okay.
So let me give another example. So suppose we are saying that yes, Rohit Sharma is expected to make 100 every match that he plays in the World Cup. That is a given fact. Now I'll say that he will be playing against Australia, against New Zealand, that we have not played earlier. So probably as New Zealand is a very strong team, he'll make less than 50. Now the null hypothesis is he'll make 100, but the alternate hypothesis is less than 50. That is challenging the norm.
Okay. Got it.
Okay. Now let's take an example. So probably throughout this study, throughout this session, I'll use this example as the reference point. Okay. So suppose a floor packaged by a manufacturer is sold by weight, and the particular size of package is supposed to be to average 40 ounces. Now suppose the manufacturer wants to test to determine whether their package process is out of control as determined by the weight of the floor packages. Okay. He wants to evaluate whether this fact is correct or not. Okay. So the null hypothesis here will be whatever is the obvious thing which is existing previously, which is the average equals to 40 ounces. Now the test wants to determine whether their package process is out of control or it is not 40. Hence, this is the alternate hypothesis. Anybody has any questions around it? If this is clear, we'll go ahead. Because this will keep getting confusing eventually. Okay, next slide then. Okay, so now after this hypothesis testing, as we have found out the null hypothesis and the alternate hypothesis, now this whole testing is of two types. One is single tail test, one is double tail test. Now what do I mean by that? Yeah, so let me see this graph. Single tail test will mean I look at only one direction of the tail, either this or this. Two tail test will mean I look at both the tails of the graph. Okay, just have it in mind. We'll get a bit more clarity later. So yeah, we'll produce either one tail or two tail test. The hypothesis shown already for the floor package manufacturing problem are two tailed. Okay, now how will you identify which one is two tail test or which one is one tail test? A two tail test will always use equal to in the statistical hypothesis and are directionless in the alternate hypothesis. This is the alternate hypothesis and it is directionless. Okay. Now, how will you give a direction to this value? You can either say it is greater than or less than. Then we can understand that I have to go beyond 40 or below 40. That will be a direction for this test. In this particular example, if the process is out of control, plant officials might not know whether their machines are overfilling or underfilling packages, right? If I establish, so if through my experiment I find out that it is not equal to 40, but even after finding this, the business guys will not understand that I need to get a bigger bag or I need to get a smaller bag. What is the difference? So here it will only prove that it is not equal to 40, but it will not prove that it is greater than 40 or smaller than 40. This kind of scenario is called two-tail test. Okay, let's see one more example to understand it better. Suppose a company has held an 18% share of the market. However, because of an increased marketing effort, company officials believe the company's market share is now greater than 18%. Right? And the officials want to prove it. Now here, what is the obvious thing? That the market held by the company is 18%. This is already there. But then the company's officials, or the example that I gave of the director, say that now it is greater than 18%. Okay. And if someone has to prove this, we have to make this statement as an alternate hypothesis. So in the floor package problem was that it is out of control. It was not about greater than or smaller than. But in this case, is saying that is now greater than 18%. So the alternate hypothesis is greater than 18%. This is a one-tail test because I know I have to go in only one direction. One-tail tests are always directional, and alternate hypothesis uses greater than or smaller than sign. A one-tailed test should only be used when the researcher knows for certain the outcome of an experiment is going to occur only in one direction. In the previous problem, they are not sure, probably the packaging problem. They wanted to establish the fact first that if it is equal to 40 or not. So this is the difference between one-tailed test and two-tailed test. Do we have doubts? This is an essential concept. Please understand. I can explain it with more examples. If we have doubts, please tell.
Yeah, we can see some more example, even though I'm very clear.
Uh, if you are clear, why don't you give an example? Then probably I'll try to change it.
Okay.
Okay, let me give you a scenario.
Okay.
You give an example on it. So let's see. Probably Ronaldo scoring a goal in a football match. Okay, why don't you make it a two-tailed test?
Okay. So, like generally, for null hype, like if we say Ronaldo, like generally goals like 3 goals in a game. So that will be the null hypothesis, and alternate.
Uh, Sorry, I didn't get that. What did you say?
No, I'm saying like generally he does the goal, right? Like 3 and 4 goals in generally each games.
Take a random number.
Yeah, 4 goals.
4 goals, okay.
Yeah. And for that alternative hypothesis, we are thinking we are not sure in the next game he will be doing the 4 goals or not.
Okay, so we present it in this way. So
Yeah,
what will
so
be the hypothesis?
H naught will be 4.
Mu equal to 4, right?
Yeah, mu is equal to 4, and alternative hypothesis mu is equal mu. Yeah, just I don't know what we say.
Not equal to,
Not equal to 4. But
okay.
in yeah, but in two tail, we don't know. Like he will be doing 4 goals or not. We are not saying any greater or less than this number.
So it is two-tailed.
Yeah,
Okay. So what will be one-tailed?
one tail will be if we say he will be doing 4. No, okay.
Vaishali, why don't you tell what is one tail for this? Take an example.
Yeah, for this example, right?
Yeah, for the Ronaldo case that we are saying that Ronaldo is on an average scoring of 4 goals per match. Why don't you give an example of what could be a one-tailed test here?
So on an average, one tail test will be, since we know its average is 4, so we are certain that an outcome is going to occur. It will be 4 or more than 4.
Okay, so if somebody says it is less than 4, then
So it is between less than 4, or it will be between 0 and 4.
yeah, but it will be one-tailed test or two-tailed test.
Oh, whether it will, which will fit best, you mean?
Yeah.
Um, since we know the mu,
Uh,
then I think one tail test will be better. Because we know the certain that the outcome of an experiment is
Perfect.
go a certain way.
Yeah, you know the direction. It is unidirectional, right?
Yeah, so I think one tail is better.
One tailed. It will be one tailed.
Yeah.
When uh, Harsha, I saw your response, but I didn't quite comprehend what you have written. Can be less than 2 or greater than 2 or equal to 2. Two-tailed. I didn't get that. Can you just tell? Are you able to speak?
Our current state, one tail is pretty straightforward. Let us say Ronald used to score 2 goals. So when it comes to two tail, it can be less than or greater than or equal to 2 because of feature state analysis. That's what I'm thinking.
No, actually. So what I'm saying is, if you know whether it is, if somebody is claiming that he'll score more than 4 or less than 4, then he's particularly sure about the direction that he wants to go, right?
Okay.
If he's saying greater than, he is saying probably 5, 6, 7. While if he's saying less than, he is probably saying 3, 2, or 1 or 0. Those cases are single tail test because he knows the direction that he wants to go. Okay.
Okay. Okay. Now I
It
see.
will
Okay.
it will be either greater than or less than.
Okay.
Now, when will it be two tail test? That is a case where he is not sure of what is going to happen, but he just want to test whether it is 4 or not. He is basically saying that it is not equal to 4. Those cases are two tail test.
Okay. I opposite. I described it in opposite. Okay. Now I clear. Okay.
Clear, right? Okay.
Yeah. Thank you.
Yeah. Let's go ahead then. If this is clear. So I'll tell you about a methodology that is usually used in our day-to-day lives. We call it as HTAB. What does it stand for? It means hypothesize, test, take an action, and then present it to the business or determine the implications to the business. Okay. Now these are the steps. Those are taken while solving any problem that you'll face in your data science career. Why don't we mute everybody, please mute yourselves. May I know who is this 18475? Can you please introduce yourself? Okay.
Hi, this is Harsha. Today I'm attending my first class.
Okay. You are also in the name of Harsha K.
Yes, I muted my laptop and attending class from my cell phone.
Okay, so just a quick introduction, Harsha. Like, what do you do? Have you attended my previous classes or sessions?
No, I went through demo classes and a couple of recorded sessions I went through. And
Okay.
but today is the first class I'm attending, Go Live class.
Okay, so
My
Harsha,
yeah, go ahead.
so I think probably you will have to read through some of the material,
Yes, okay, yeah, I'm catching up. Yeah,
solve some of the assignments to probably get in touch with this class.
yeah,
Okay, including this material, I have uploaded it already in the system.
okay,
Okay, yeah.
okay. Thank you, Hitesh.
Yeah. So I was saying about this methodology, which is HTAB usually. So what do we do? First step is to establish the null and alternate hypothesis, which will give us direction. What do we want to achieve or proceed with? Then second phase is the test phase. Now what do we do in test phase? We determine the appropriate statistical test that needs to be taken to establish this or reject this hypothesis. Then we find out the set of alpha, which is also called as the type 1 error. It is the same exact alpha that we were dealing with till now. Then establish the decision rule, whether it is greater than, less than, not equal to, whatever it is the decision rule. Then gather the sample data and then analyze the data. Okay. And then take a statistical action on it. After you take the statistical action, you get a real result out of the data that you have collected, and then tell it to the business. What are the implications of your study, or how do they improve their business using this, or how is it really impacting, or what is the loss their business is going to do with it. Okay, so this is the step. We'll go through a simple question where we'll solve it using these methods or a step-by-step approach. Okay. To give you a better detailed explanation, so the task one is usually hypothesizing, which is establishing a null and alternate hypothesis, as I told. Okay. So it is important that a business researcher clearly identify what is being tested and whether the hypothesis is one-tailed or two-tailed. So basically, this is the cusp where you want to reach in task one. What you want to do in task two is to select the most appropriate statistical test to use. In selecting such a test, he needs to consider the type, the number, the level of data being used. So this is where all your categorical continuous kind of discussions will come into play. It's nominal, ordinal, or what kind of data you are using. Is it ratio, or it has intervals, or what is it? Okay. And then you will identify what do you want to analyze. The measurement of central tendency, whether it is mean, proportion, population variance, or what it is. Okay. In addition, business researchers should consider the assumption of underlying certain statistical tests and determine whether they can be met in the study before using such tests. Okay. So what does this line mean is, though you will finalize that this statistical test is good for it, but then they have certain underlying assumptions. Like in the last class, we were looking at a t-test where it had limitations saying that the number of n should be less. So those assumptions need to be satisfied. Only then we could use a particular statistical test. That is done in task 2. After that is done, the value of alpha is set, or in how much confidence you want to achieve the solution. Okay, which is probability of committing a type 1 error. We'll discuss it later, but As we have already seen, it is 0.5, 0.1, 10, 0.001. Correct? Now what will task 4 mean? It is using the alpha that we have found out here and the test statistic that we have found out here. The critical values can be determined. Okay. These critical values are used at the decision step to determine whether the null hypothesis is rejected or not. These two steps will form something as critical value, which will help us determine this step is valid or not. Okay. I have not discussed the p-value method in this class, but then yes, there is a p-value method, which is nothing more than a probability method, which I think I have tried to explain how a normal curve is formed. It is formed using, or it depicts the probability basically. And this p-value method uses that concept. Okay. So are we clear with these steps? Because we'll solve a problem and you'll have to go through these steps yourself.
Yes.
It's better we clarify these steps before that. Okay, maybe when we'll solve, we'll come back again. Okay, so now how do you decide whether you're going to reject the null hypothesis or not? So now I think we have discussed this a lot of time that this is a 99% confidence or 95% confidence or whatever it is. The region inside it means a non-rejection area. The region beyond it is a rejection area. Okay, and this value, which we usually use to get as 1.63 or 1.95, those are the critical values. Or in a layman's term, it is a threshold, which we are saying if it goes beyond 1.65, it is not in our reach. Okay. So if our results lie in this non-rejection area, we do not reject the null hypothesis. If it lies in the rejection region, we reject the null hypothesis. Okay. So basically we always reject or accept the null hypothesis. The alternate hypothesis is kind of a default. If it depends on what happens to the null hypothesis, and then we decide the fate of alternate hypothesis based on that. Make sense? So this diagram also shows the 40 ounces, which is the packaging problem that we are looking at, floor packaging problem. 40 ounces be the mean. Okay. Well, if anybody has any doubt, please, before I go ahead. I think we have discussed this not many times before solving many problems around Z value. Okay, I'll go ahead and introduce you to something called as a type 1 error and something called as type 2 error, the favorite question of every statistician. So what do you mean by type 1 error? Okay. A type 1 error is usually committed by rejecting a true null hypothesis. Now, let's talk about the example that we are taking Salman Khan's movie making 200 crores. Okay, so a type 1 error would be a movie that is going to actually make 200 crore, but you are saying that no, it will not make 200 crore. Okay, what do I mean by that? The experiment that I'll do, the results that I'll get will prove that the null hypothesis stands right. But then by mistake or due to some error in my study or some of the wrong values that I've collected or wrong sentiments that I collected, I by mistake reject the actual value. That is a type 1 kind of error. Okay, let's go through these examples. With a type 1 error, the null hypothesis is true, but the business researcher decides that it is not. As an example, suppose the floor packaging process actually is in control and is averaging 40 ounces of flour per package. Suppose also that a business researcher randomly selects 100 packages, weighs the content of each and computes a sample mean. 100 packages of this flour. Okay, it is possible by chance to randomly select 100 of the more extreme packages, mostly heavy weighted or mostly light weighted, resulting in a mean that falls in the rejection area, probably in this area or somewhere here. The decision is to reject the null hypothesis even though the population mean is actually 40 ounces. In this case, the business researcher has committed a type 1 error. Did we understand? Let me give you one more example of type 1 errors in our daily life. Suppose a doctor is looking at a patient. He has a cancer actually, but then due to some wrong diagnosis done by a doctor, he says that no, there is no cancer in this body. He committed a type 1 error. Okay. Can you give me an example of a type 1 error, please? From your real life. Why don't you guys type it? Each one of you, please give an example of a type 1 error. These might seem simple, but eventually this is the thing that will confuse you the most. So please. Judge declares that the innocent committed crime based on circumstantial evidence. You are saying he's actually innocent, but then he is proven guilty. Makes sense? Makes sense. Yes, this is a type 1 error. Okay. So look at this matrix. Okay. This matrix is famously called as the confusion matrix. Mark my words, it will confuse you like anything. Okay. But to make it clear now so that you don't get confused, suppose this is the true state of nature, true and false. He's actually innocent. These are the cases where he's actually criminal. These are your actions. You accept them or reject them. Well, wait. Sorry, I made a mistake. It is not accept, it is fail to reject. This is reject. There is a difference between accept and fail to reject, right? Fail to reject says, I'm not sure about null hypothesis. Accept means I'm accepting the alternate hypothesis. So there is a difference. So what is type 1 error? The state of nature is actually true, but then you are saying it is wrong. No, it is not. So love is not equal to indifference, right? There is a difference between indifference and, hatred and indifference. There is a small gap between them. Indifference is actually not bothered or he doesn't know or is unsure. A hate is he's sure that he's hating you. Are you getting the analogy? I know it might be a bit weird, but this is the best I could come up now. Is it clear? So what is the difference between this? Fail to reject. Exactly. So a judge says that the evidences have been tampered. I don't know. Please come up with further evidences, and till then, the court is adjourned. Like, I am indecisive now. I reject. I cannot reject also. Yeah. So there is a 3-step process. Either you accept, either you are sure of something, then you are not sure of something, then again you are sure that it is not that thing. Exactly. The state between rejecting and accepting. Okay. These are really tricky waters, so I want you to focus. So in this case, the true nature, let's take the matrix here where all these columns are true nature, and still we got to reject it. Those scenarios are called type 1 error. Okay. Now type 1 error is called alpha. The same alpha that we have been dealing with till now. You remember we use that alpha to find out what is the threshold or what is the range that is lying beyond that 90% or 95%. This is the same alpha. Correct? Now, can you try to formulate or take your time and try to formulate what could be a type 2 error, which we also called as beta? Look at this matrix. As I said, this is the true state of nature. This is the state of nature. This is true and this is false. Innocents, guilty. Innocent and accept, innocent and reject. Guilty and what is this? Guilty and what is this? So basically, what is the opposite of type 1 error? He is innocent and you still put him in the bars. Let me give you one example of the famous example of type 2. Woman is not pregnant and the doctor says he.
Yeah, or maybe like same as cancer patient. They are not having cancer like cells, but by report, blood test, it says.
He has cancer,
Yeah,
right?
yeah. Because it's kind of negative reports, but yeah, we are making as a correct.
So you're clear? This
Yeah.
is type 1 error. This is type 2 error. Okay. I have not written the definition here. You can find it anywhere, but then I want you to develop a notion around it. When you look into it, you should directly get a hold of it.
So do you think the type 1 error is like more like, so what is the difference between the type 1 and type 2 error? In both cases, we are making error, right? Opposite.
Yeah.
It's kind of false.
Yeah. Still, we had to categorize them as type 1 and type 2. Why do you think we had to categorize them? We had to categorize them because in different situations, different things hurt a business. Okay. In some scenarios, your type 1 error will hurt the business. In some scenarios, type 2 error will hurt the business.
Correct.
Let me give you an example from a thing that I'm trying to do currently in my job. Okay. So I have been given a problem by a retail company saying that please help us predict which of our customer is going to churn out or is going to move out of our business. Right?
Correct.
Now I run all the algorithms that I know, I try different things, and then I produce this confusion matrix to them. Now I'll have two types of error. First type of error is he's actually going to churn and I am saying he'll not churn. Okay. And the type 2 error is he's not going to churn, but I'll say he'll churn. Can you tell me which error will hurt this business the most?
So in type 1, we are claiming like he will not churn,
Right?
but he will be staying.
Is
And
that type 1 error?
yes, right?
Sorry, would you come again?
No. So in type 1, what we are saying, that's I'm confused now.
Okay.
Again, yeah.
Let's start with the whole process itself, right? Now somebody came and told me I want to identify which guys are going to move away from my business or not.
Correct.
Now tell me what is the null hypothesis here? And tell me what is the alternate hypothesis here. Vaishali, you can also type. Aarti, you can talk meanwhile. Harsha, please, you can also think and type.
So null hypothesis, we don't know like he will stay or not. We are saying he is going away.
Oh, we are not saying anything. No.
No, so what was our question? Like we are.
Okay, so a business comes to me and says, you see, I want to identify which guys are going to move away from my business or not going to continue doing business with me. Do something and tell me which are the guys who wants to go away.
So this is like null hypothesis.
What is the null hypothesis?
We just want to see.
Okay, Aarti, if you had a business.
Yeah.
You have a good business. Okay. You are like, how do I say? You're like Louis Vuitton or Ford or something. You will always think that your customers will stick to you, right? Because you are doing everything in this world to keep them with you. Correct?
Correct.
So the null hypothesis here will be all the customers are with me. Nobody is going to churn. Churn equal to 0.
Correct.
Because that is the usual state. Every business guy or CEO has a usual state of this, that nobody is going to churn and things are fine now. But then somebody said that no. Exactly, Vaishali. But somebody said that no, some of the guys are going to churn away.
That is alternate hypothesis then.
Alternate hypothesis is not equal to 0.
Yes.
Okay. Or is it greater than 0?
Not greater than 0.
Vaishali, you said the alternate equal to some percentage will stop doing business. So suppose I say H0 equal to 0 is my null hypothesis, where 0 means number of guys who are going to churn is equal to 0 is my null hypothesis. What will be HA? It will be greater than 0.
Yeah, but not less than. Could be less than 0 to, yeah, in bidirectional.
Bidirectional is
Two-tail. Two-tail.
Bidirectional is not equal to 0, right?
Yeah, but it could be less or smaller than.
If it is less or greater than, it is unidirectional. One tail test.
Oh, sorry. Yeah, sorry. Yeah.
Correct?
Yes.
Vaishali is saying it should be greater than 0, which means that yes, the churn is going to happen. The number of guys who are going to churn is greater than 0. Correct? That is our alternate hypothesis. Did we understand it? Aarti, it's okay. I'll explain it again. If you have not understood, please tell me.
No, I got that. Yeah, I got that.
Got it, right?
Yeah.
Now I did some classification method. I adopted some process and I found out the result. Now my model, because it is not a human being, it will make some errors. Now what it did, it made some type 1 error and type 2 error. Now, will you tell me what is type 1 error here?
The type 1 error, I will say, in this case, the people will churn, but he's not going to churn.
When
No,
actually the actual state is?
he is staying.
The actual state is he is staying.
Yeah.
But I am saying that he is not going to stay.
Then it will be type 2 error. Oh, he's
Think
not
about
going.
it. Think about it. Type it.
Okay.
Type your question in a notepad and then copy paste it in the group chat. Especially you can also do the same. Take 2 minutes. Please do not throw an answer. I'll be back. Okay. So Vaishali has correctly stated what is the null hypothesis, which is all vendors will keep doing business. So you're saying type 1 is there will be no churn, but you will say that yes, some are going to do churn. You will say as in your experiment will say. There will be no churn, and you will say that yes, there will be churn. Is this type 1? And type 2 is there will be churn, but you will say there will not be churn. Correct? Is everybody with us? So now which will hurt the business the most? It will churn, and you will say it will not churn. Why will the other one not hurt? Aarti, you understood, right? Why type 2 will hurt the business most? Exactly. It will hurt, but it will hurt very less. We had to differentiate type 1 and type 2 errors because though both are errors, both the things hurt in or have different impacts in different scenarios. Correct? Now, good that you asked this question. We cleared out many concepts. In a scenario where a guy has a cancer and a doctor is saying you do not have a cancer, will impact him more than the case where he has no cancer and the doctor says yes, you have cancer. In that case, type 1 error will hurt more. In a case where a woman is pregnant but a doctor says no, you are not pregnant, versus a woman is not pregnant and a doctor says yes, you are pregnant, what will hurt more? Well, I think this is a dicey question. You're saying not pregnant and he'll say yes, pregnant. Yeah. But no, but the cancer one is not dicey, right? You are having cancer, but the guy says you do not have cancer, you'll die. But if you do not have cancer and a guy says you have cancer, you'll take medicine uselessly, but you'll not die. But yeah, I mean, you understand what I'm saying, right? Yeah, I mean, okay, so but in a business wise, there are different things that would hurt you differently in a different scenario. That is why these two types of error had to be carved out. Okay. When we work through the algorithms, we'll understand that how same algorithm will cause you different type of things and how will they impact each other. Okay. Okay, now this is quite clear, I think. We'll go to next question, next slide. Okay. So now testing hypothesis about a population mean using the Z statistic. And I think the Z statistic we have used quite a few times, right? One of the most basic hypothesis test is test about the population mean. So probably all the questions that we have done till now is all about the average or mean or something like that, right? Now suppose a business researcher might be interested in testing to determine whether an established or accepted mean value for an industry is still true, or in testing a hypothesized mean value for a new theory or product. Correct? Now let's take an example. A financial investment firm wants to test to determine whether the average hourly change in the Dow Jones average over a 10-year period is 0.25 or not. This is one question where we used average. A manufacturing company wants to test to determine whether the average thickness of a plastic bottle is 2.4 millimeters. A retail store wants to test to determine whether the average age of its customer is less than 40. Right? Usually all average type of questions. Now, how do we use Z statistic around average? We know this formula already. Z is equal to x minus mu by sigma by root n. Okay. Now let's read this question and let's follow the 4 steps that we chose earlier to prove the hypothesis or to reject the hypothesis. Okay. Now a survey of CPAs, think of some kind of profession, okay, across the US found that the average net income for sole proprietor CPA is this much. Suppose the average salary of these kind of guys is this much. Now, because this survey is now more than 10 years old, an accounting researcher wants to test the figure by taking a random sample of 112 sole proprietor accountants. Okay, so proprietor accountants probably think of the same profession in US to determine whether the net income figure has changed. Now the researcher could use 8 steps of hypothesis testing to assume the population standard deviation of net income for the sole proprietor is this much. Standard deviation is this much. Okay. Now, can somebody tell me what is the null hypothesis and what is the alternate hypothesis here?
So the null hypothesis in this case, the researcher wants to check this average net income is $74,914.
Okay.
And for alternate hypothesis, it could be less or higher than this salary. Because they are not saying that net income figure has changed. They are not telling about it's increased or decreased.
Okay, so what will be the null hypothesis?
We just want to know like that there is change in that sale, the average income
Okay, so what will be the null hypothesis?
is not equal to 74,914.
Is that the null hypothesis or alternate hypothesis?
Oh, sorry, sorry, alternate. That will be a null is 74,914.
Okay.
Yeah, from the survey, like they found like this is a salary, average income of that CPAs, but the alternate will be it's not equal to 74,914, and it could be two. It's a two tail.
It's a two-tailed test. Okay. So we will probably use a Z statistic for this. Okay.
Yeah, because there are 112 people, so we are not going to use T statistic.
Great. Great. Okay. So what is 112 in this? What is 112?
And number of sample.
What do we have more?
No, I didn't get that. What do you mean?
What else do we have
Oh,
in this
what do we
question?
have? Oh, okay, okay. The average means the sample is X bar.
Okay.
Oh no, we will say This will be the population, then mu, 74,914.
Yeah.
And then mu is equal to 14. The standard deviation is 14,530.
Okay.
And the sample mean
What else do we need?
x bar, sample mean,
Okay, we need the sample mean. Okay, the sample mean is 78695.
786. Okay.
What all do we have and what do we need more?
I think we can calculate z score on that basis. All with all these numbers.
Right? Why don't you go ahead and calculate the z-score for this using all the numbers?
Yeah.
The X bar is
X bar is 78695.
It's 78,640. No, this z.
So X bar is, I gave X bar 78695
Yeah, minus 74914.
divided by
14,530
divided by
square
root
root
over
of
of,
112. Yeah,
correct. So what does it give?
it gives 78640.
What? How can it be so big here?
Yeah, this. Okay, let me see.
Yeah, Vaishali, your answer is right.
How come?
Uh,
Let me see.
74914. Right. I have
2.75.
2.75. Yeah, makes sense.
Yeah, that's what I think.
2.75.
Yeah, that is the z score.
Z-score. Okay, great. But what will you do of the Z-score?
So now we need to find the range. So z score, we should get the two range. Or
What
what?
range? What range?
Okay. We need to find that figure has changed.
Yeah, how do we test the hypothesis? You have a Z value. Now to test it, you got to have something that you need to compare it with, right? You have a Z value calculated out of these problems. No, it's not greater than 0. No, I think I'll tell you this. I think it's difficult for you
I
to.
think estimating the population mean. using
Yeah.
that formula?
Let me just tell you. Okay.
Okay, sure.
I think this will be a bit difficult. So what do we do? As you know, to test something, we need to have two things. I have calculated something and which is already there. And then I compare and say that which is good or bad. Usually in our real life also, what people tend to do, which should not be done, but tend to do is, Sachin has scored so many centuries in so many matches. Now Virat Kohli has scored so many things in so many matches. And then they give a comparative study. Nahin, so Virat Kohli has done so much better or so much less, or Sachin had done this, that, like this, right? Now, what is Sachin? Sachin is a reference point. And rest of the guys are contenders or a sample, newly evolved sample. Now, from the sample, you have found out the value of the Z. Okay, you found out that it is 2.75. Now, you need a reference point. Now, what is the reference point? The reference point is the normal curve. And in the normal curve, you need to have a confidence level. In this question, the confidence level is missing. Okay, you got to ask that anytime you find a question like this. That yes, you want to test this, but then in what confidence level do you want the answer to lie in? Okay, so say, suppose for this question, we'll take the confidence level to be 95%. Okay, now the alpha becomes to be what? 0.05 point alpha by 2 is, can we assume confidence level or make it as close to 100 as possible? Yeah. Usually what people do, shrewd people, want it to be 6 sigma. They say that I want a confidence of 99.6% or 99.9% and something. And then they try to calculate the values. Okay. Now, chalo, for your reference itself, let's take the alpha to be 99%. Now, the confidence to be 99%. Alpha kitna hua? 1 minus 0.99. Correct? Now, what is alpha by 2? 0.005. Correct? And the value is coming to be 2.575. Now you have calculated your value to be how much? Is it exactly 2.75? I'm asking you, is it exactly 2.75 or is there a decimal value in it?
$2.753.
Okay. So suppose it is 2.753. Okay. Now look at this curve. Now what I'm saying is I want my results to lie in 99%. Suppose this is 99. Okay, so this is a two-tail test or a one-tail test first? I mean, I have to look to positive values only or only negative values?
Both.
Or to both? Both, right? So this is
Two-tail
a
test.
two-tail test. Now this is 99%. So I need to find out this threshold value or the Z value of this critical value. Critical value for 99% is 2.575. 2.575 plus 2.575 minus. Now I'll reject the null hypothesis only when the Z value crosses this. My Z value is 2.753. is 2.5, 2.753 is in the rejection region. So I'll reject the null hypothesis.
Can you repeat that again? Since the z value was 2.753 and we got our calculation after estimating that mean value
2.753 you got?
from z. Yeah, when we calculated z value.
Yeah, when you calculated z value, you got 2.753, right?
Correct.
Now from the reference point, so what Sachin is saying that if you have to have a 99% confidence, your z value should lie between plus something and minus something. That something is 2.575. You get this statement? Normal curve is the reference point. Normal curve is saying if you have to have a confidence of 99%, the z value will lie between plus 2.575 to minus 2.575. A normal curve. If it lies beyond that, you will have to reject the null hypothesis. You don't reject the number, you reject the null hypothesis. All you are doing here is establishing the fact of the hypothesis that you are trying to prove. Okay, and your hypothesis here was that the average value
It's 74,000.
is $74,914. Now, if you will reject the null hypothesis, you will come to a conclusion that is not 74,914. Is something else. In this study, you are not going to find out it is greater than or smaller than, because it is a two-tailed test. It got a lot of confusing, right?
So whenever we have to do this kind of testing, so we need to compare these two value. You mean like the confidence level, the alpha, what we got that, and then the z value, right?
Yes.
Okay.
Yes.
Always then we should come to the point we have to reject it or accept it.
Yes. Not always for this kind of problem, because you are using z statistic,
Okay.
you will compare it with the z statistic.
Okay.
There are many other things, like for t statistic, it will be different. Correct?
So yeah, that's true. So to accept that it should be same value as z and that confidence level thing, that formula we put in, we should
It
have the
should be less than equal to.
less than or equal to. Okay. To
ये
accept.
ग्राफ देखो ना, ग्राफ
Yeah.
देखो, ये क्रिटिकल वैल्यू है, क्रिटिकल वैल्यू से less than or equal to that. Either it should be minus 2.575 से लेके plus 2.575 तक होगा तो चलेगा.
Okay.
I'll be okay with the value. I'll say that no, the average salary is still is 74,914. If it goes beyond that, then I'll say that no, it is not. With 99% confidence, I can say that it is not 74,914. Otherwise, you would have said with 99% confidence, I can say that it is 74,914.
If it is less than or equal to that value.
Yeah.
Okay. I know it's confusing, but yeah, you'll get it.
It's okay. Everybody in the world got confused here.
Yeah, the probability and all these things are like that. So
But you got to pay attention here because everything will roll down and trickle down from here itself. It's all about hypothesis testing. So in this problem, do you have any question? Okay, so the homework for you is to not do any more homework to solve this problem again. That's it. With a 95% confidence.
okay.
It for 99, do it for 95%. I have uploaded this already. Or I think they would have. Yeah, so this is uploaded already.
Okay.
Please go ahead, take some time. This is not heavy, but confusing. Focus on type 1, type 2, the hypothesis, this problem, and please go through these processes once, understand it, because these are asked in the interviews or these are of lot of importance for business guys.
So I don't see they uploaded that assignments. You said that assignment, right?
Not assignment, this presentation.
Oh, okay. Yeah, that I see that. Yeah. So the question only that's the 95 confidence interval, right?
Bus. And
Okay.
read it and read this presentation 20 times.
Yeah.
How many times? Because this is the only thing actually which is confusing. Eventually it will get easier.
Correct. So when we will be starting that programming Python and all, so this is the last chapter in this statistics?
No. This is not the last chapter.
Oh, okay.
On programming, I was thinking if programming is important or not. Okay. No, let's focus on this only. Programming is easier than this.
Okay.
Okay.
Yeah.
I'll teach you programming, no issues.
No. I'm just checking like this is like I thought like this is done. So statistics is done after the
So
today.
because if this is done, everything else is easier comparatively.
Okay.
That is why I'm taking the maximum time.
Okay.
Okay. So I think that is it
Okay.
for
Yeah.
today.
Thanks.
We have 2 more statistics class to go ahead. Okay.
So the next weekend will be done, I think, hopefully.
Yeah.
Okay.
2 more classes of statistics and then we are done. We'll start with Python and we'll start our regular machine learning stuff. Okay.
Yeah.
So these
Thanks.
stats we are going to use in the Python or
Yeah. I mean, now you are using Excel for this Z value and all.
Oh, okay.
This hypothesis testing and all. So everything will be quite easier then. But then you need to understand this. Otherwise, it's of no use.
So
Okay.
usually in Python, there are formulas already built in, or we build those like logic.
There are already built in.
Okay. We just use it.
I mean, yeah. Because people have done PhDs and built it. I don't think in 2 days we can catch up with them. But yeah, in real life, but then when we code in for different clients, we have to use all the mathematics. And so like this is x minus mu by sigma by root n, you got to write your own function and then do that.
So you are saying that the logic, the business logic we have to add, but the package is already there. Right?
Yeah, I mean, you have to play around with it.
Okay.
But then to be able to play around with it, you need to understand the concepts.
Okay.
Otherwise, you will use it superficially and might not get the result.
Mhm.
Correct?
Yeah.
Okay. So
Okay,
then,
thank you.
All right.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.